It's genuinely surprising, isn't it? To think that, well, until the 1990s, a whole category of these really unusual theropod dinosaurs was just completely unknown.
Absolutely unknown. Yeah.
And that's really our starting point for today's deep dive.
Mm-hmm.
We're looking into Albertonykus borealis, a small, kind of peculiar dinosaur found right here in Alberta, Canada.
And what makes it so compelling, I think, is the context, where it was found.
Yeah.
I mean, these bones turned up in the exact same bone bed that gave us so many Albertosaurus fossils.
Giant tyrannosaur.
The apex predator. Yeah.
Yeah.
And then you find these delicate little bones right alongside them. It's unexpected.
Really paints a picture, doesn't it, of, life back then.
It really does. We're talking late Cretaceous here, Maastrichtian age. So maybe 68.5 million years ago from the Horseshoe Canyon Formation.
Okay, so you've got this, concentration of huge predators.
Yeah.
And then, boom, this totally different tiny dinosaur pops up. So our goal today really is dig into what makes Albertonykus unique and what its discovery tells us about, the bigger picture, dinosaur evolution, those old ecosystems.
Mm-hmm.
We've got the scientific papers, the original descriptions, and some news reports, too, which help visualize it all.
Absolutely. And the name itself, Albertonykus, it kind of gives part of it away, right?
Alberta claw.
Alberta claw, yeah. Points to where it was found, obviously, and hints at, well, one of its most standout features.
And its classification.
Yeah.
Where does it fit in the grand scheme?
Okay, so scientifically, it goes Eukaryota, Animalia, Chordata, then Dinosauria, Sauriskia, Theropoda, and then it slots into this specific family, Alvarezsauridae.
Ah, right.
And the species is Albertonykus borealis.
And Longrich and Curry, they're the ones who formally described it, back in 2009.
That's them. Yeah, Longrich and Curry, 2009. And borealis, the species name, just means north. Simple as that. Again, pointing to Canada.
So the actual discoverer,
Right.
2002, you said, Phil Curry's team.
That's right. Phil Curry's team, 2002, at the Albertsaurus site in Dry Island Provincial Park. A site Barnum Brown had actually poked around in way back in 1910.
Wow.
But the really cool part is how they realized it was something new. Nick Longrich was going through what everyone thought were just more Albertosaurus claws, and he noticed some were different, smaller, and realized, hey, this isn't a Tyrannosaur claw at all. This is an Alvarezsaurid.
No way. So, hidden in plain sight among the giant's remains.
Pretty much finding a tiny claw in a mountain of huge ones.
That's incredible attention to detail. And it wasn't just those initial pieces, right? They found more later.
Exactly. Once they knew what to look for, other Albertonykus bits and pieces started getting identified in existing museum collections. Stuff that had been collected years ago but just hadn't been recognized.
Right, okay.
And finding it here in North America, that was a pretty big deal.
Why is that?
Well, because most Alvarezsaurids known back then were from Asia and South America, so finding Albertonykus here started to bridge that geographical gap. It suggested maybe they were more widespread than previously thought.
Okay, let's get a picture of this thing. You said it was small.
Mm-hmm.
How small are we talking compared to, say, Albertosaurus?
Oh, tiny in comparison. Maybe 1.1 meters long. That's about 3.6 feet.
Yeah.
And weighing probably only around 5 kilograms, maybe 11 pounds.
Wow, that is small. The smallest known one from North America.
Yeah, the smallest North American Alvarezsaurid we know of so far. And it had that classic Alvarezsaur body plan.
Which is?
Okay, think long, skinny hind legs, probably pretty fast.
Right.
A long tail, likely quite stiff, maybe for balance when running. And then the arms, the forelimbs are the really weird part.
Weird how?
Super short. Surprisingly short, but really powerfully built. And each arm basically ended in one single large claw.
The Alberta claw.
On the Alberta claw itself, yeah.
So what's the thinking? What was it doing with arms like that? What did it eat?
The best hypothesis, and it's pretty well supported, is termites. Specifically, wood-nesting termites.
Termites. Okay, how do those arms help with that?
Well, you see, those strong arms, they weren't really long enough for digging big burrows in the ground, but they seem perfect for ripping into rotten wood.
Ah, okay. Like tearing open old logs.
Exactly. To get at termite colonies living inside. The structure suggests a lot of power for sort of hooking and tearing.
That makes a lot of sense. And do we know anything about its head? Did it have a specialized snout?
We don't actually have skull bones for Albertonykus itself, which is a shame. But we can look at its closest relatives, especially from Mongolia, where they've found more complete skeletons.
And what do those show?
They show these Alvarezsaurs generally had long, quite delicate snouts and tiny, tiny teeth.
Not for chewing big things.
Not at all. More like little pegs. perfect for slurping up small insects like termites. Think kind of like a modern anteater or an armadillo in terms of function.
Okay, so the skull evidence from relatives fits the termite idea too.
It really does. That big thumb claw breaks open the log, and the slender snout with tiny teeth probes in to get the insects.
Did they actually, like, check if termites were around back then
Yeah.
in that specific place?
Oh yeah, they did that work. It involved looking at the fossil record of social insects. Ants, for instance, weren't really a big part of the ecosystem yet in the way they are now.
I see.
And those big mound-building termites you see today, they didn't show up until much, much later in the Eocene.
So that leaves.
Wood-nesting termites is the prime suspect. And to kind of clinch it, researchers looked at petrified wood from the Horseshoe Canyon Formation
Yeah.
and found fossilized boreholes, little tunnels in the wood that look remarkably like termite damage.
Whoa. So the crime scene had the evidence.
Basically, yeah. Forensic paleontology.
That's fantastic. So
Yeah.
stepping back a bit,
Hmm.
what does Albertonykus mean for the bigger picture, evolutionarily speaking?
Well, its position in the family tree is interesting. It seems to belong to a subgroup, the Mononychini, which is mostly known from Asia.
Okay, so a North American member of an Asian group.
Kind of, yeah. And
Yeah.
this discovery really bolsters the idea that alvarezsaurs might have actually originated way down in South America,
Right.
then spread north, up through North America,
Mhm.
and then somehow, maybe across a land bridge later on, made it over to Asia.
So Albertonykus is like a key waypoint on that journey.
Exactly. It's a crucial data point. It
Yeah.
tells us they were definitely in North America during the late Cretaceous, fitting into that dispersal model. It's not just some weird little Canadian dinosaur.
Yeah.
It's part of this global story.
It really adds a lot to understanding the biology of the whole Alvarezsauridae family, doesn't it?
Immensely.
Yeah.
And it's worth mentioning there is another one from North America, slightly younger, Triartunkus prairiensis from Montana and Wyoming.
Ah, okay.
But Albertonykus is still the earliest definite member of this family we've found in North America. It pushes their presence back a bit further here.
Okay, let's circle back to that discovery site, the Albertosaurus bone bed. You mentioned just how many were found there.
It's pretty staggering. Barnum Brown's first dig in 1910 pulled out, I think, at least 9 individuals.
9 tyrannosaurs
Yeah.
in one spot.
Yeah. And later digs, including the ones that found Albertonykus, have pushed that total to over 20 Albertosaurus. And they haven't even finished excavating the whole quarry.
That's a lot of predators together. Why? Is there a theory?
It's a big question. Why so many together? Nick Longrich, remember one of the guys who described Albertonykus? He speculated it might have been some kind of predator trap.
A predator trap?
Yeah.
Like quicksand or something?
Could be something like that, or maybe a muddy area, or just a place where prey animals got stuck easily, attracting predators, who then also got stuck or died there. It's one idea, anyway. Still a bit of a mystery.
A grim thought, but plausible.
Yeah.
And it just emphasizes again, this tiny Albertonykus was living and dying right there amongst these giants.
Absolutely, in their shadow, quite literally. And you have to keep reminding yourself, like we said at the start, dinosaurs like this, these alvarezsaurids, were completely off the radar until the 90s. Our picture of theropod diversity was missing this whole rather strange branch. It was really the finds in Asia and South America that opened our eyes.
And now the North American finds, like Albertonykus, are adding crucial detail to that picture.
Incredibly valuable detail, yeah. Filling in the map, so to speak.
Okay, so let's sort of wrap this up. Key takeaways from Albertonykus, the Alberta claw.
Well, it's this small but really significant dinosaur, giving us a fantastic look at theropod diversity right at the end of the Cretaceous in North America. Its very unique body, especially those arms and the claw, strongly points to that specialized diet, probably wood-nesting termites.
Right, the log ripper.
Yeah. And finding it where we did has these big implications for understanding how this whole family, the Alvarezsauridae, moved across the continents over millions of years.
It really is a fascinating piece of the puzzle.
It leaves you thinking, though, doesn't it? You find this small, super specialized dinosaur living in an ecosystem that seems totally dominated by giants like Albertosaurus.
Yeah.
How does that change how we think about those ancient food webs? You know, what other hidden roles were being played? What other small, maybe overlooked creatures were carving out a living in these niches we haven't even thought about yet, right there under the noses of the big guys?